Hello guys, welcome back to all. So in our last class we discussed about structure of atom, right? So in yesterday's class we discussed about electromagnetic spectrum, what is a spectrum and what are the characteristics involving in that. So in this class we are going to discuss about one more topic, new topic, that is Planck's quantum theory. So this Planck's quantum theory is proposed by the scientist called Max Planck. So very important theory. Really it's theory. This theory made a revolutionary change in physical science. So now let us see what is the Planck's quantum theory. So in last class we discussed that when we heat an iron rod, so this is an iron rod, by heating this iron rod we are giving a flame. What will happen if you heat this iron rod? First this rod will turn into red color. By increasing the temperature, what will happen? The red color will turn into orange color, and then yellow color, blue color, and finally violet color and white color also. See why it is happening like this? Because so red color having the lower energy, that is why it will appear first. By increasing the temperature continuously, the light energy emits, so the color of the light will change. It will turn into orange color, yellow color, blue color, violet color and white color. So this concept is explained in last class. So here in this part the energy is very high, but the remaining part of the iron rod, the energy is very low. Lower energy is there. So at that time the scientist thought that the emission energy is in a continuous manner, which means the energy will be in a continuous flow. Like if you take water, so this is a water tap. In this tap the water flow will be like this. It is in a continuous flow. This is a continuous manner. In the same way, the light energy, the electromagnetic energy is always emitted in the form of a continuous manner. So at that time the scientist thought that in this way, but the Max Planck thought that he broke this continuous manner. He thought that a new concept. He came out with a new thought. He told that the energy is not in a continuous manner. So the electromagnetic energy by heating either gain energy or lost energy will be in a discrete manner. See what is a discrete manner? So discrete manner means not in a continuous manner. For example, see in this way, here the water flow is a continuous manner. So when I pour some grains like this, is it a continuous manner? No. Each stone or grain will come individually. So this is called discrete manner. So the Max Planck told that the electromagnetic energy either gained or lost, whatever it may be, but the energy should be in the form of a packets. Packets means individual. That is called quanta. So the values of energy must be in a discrete manner, not in a continuous manner. So this theory is called Planck's quantum theory. This theory is proposed by the scientist called Max Planck. That is why it is called Planck's quantum theory. And he gave a relation between the energy and frequency also. See, he told that the energy E is equals to h nu, which means E means energy here. Nu means frequency. Here H means this is a constant called plancks constant, and its value should be 6.626 into 10 to the power of minus 34 joule into second. So this is the very important value. It is very useful in problem solving. And what is the value for plancks constant? In your exams also this value is very important. 6.626 into 10 power minus 34 joule second. So this is the value for plancks constant. So here E means energy, nu means frequency. He told that, one more point, this plancks constant value for all colors is constant, no? So then E is directly proportional to nu, which means energy is directly proportional to frequency. Means if energy is high, then frequency is also high. Is it clear? For example, take violet color. For violet color, its frequency is higher, which means energy is also higher. In the same way, for red color, what happened? Its frequency is lower frequency. So that is why its energy also lower. That is why while heating an iron rod, first red color will appear, because red color having the lower energy, lower frequency and lower energy. That is why first red color will appear. Okay. So this is the plancks quantum theory. Very important theory. And he told that the energy also quantized here. Quantized means what is that? It should not having any point values, which means energy also having like 1 h nu, 2 h nu, 3 h nu, because it is not in a continuous manner, which means energy should be always 1 h nu, 2 h nu, 3 h nu, like this only. It should not having 0.5 h nu value or 1.5 h nu value or 2.5 h nu, because it is having the discrete value. He told that. So energy must be quantized here. Energy also having values, even 1 energy, 2 energy, 3 energy, like this. So this is the plancks quantum theory. So basing on this theory, there are a number of theories are proposed in physical science. So this is very important theory. So now we have to know one more important topic, line spectra. So these are the basic topics, all these are. What is a line spectra? For example, in our Diwali festival, we can observe so many crackers, fireworks. So we can observe so many colors, green color, blue color, yellow color, red color, orange color, and so on. There are so many colors will come. Variety of colors will come. How do these colors will come? Do you observe? Have you any observation? So to explain this, we have to do one small experiment. So here, take a pinch of cupric chloride. So cupric chloride. So take this cupric chloride in a watch glass and add some concentrated hydrochloric solution to it. Few drops of concentric hydrochloride solution. So by adding these two, make a paste. So if take some platinum loop. So for example, this is a platinum loop. So this is a loop. So assume this is a platinum loop. If you put this paste in this platinum loop, what will happen? By heating with non-luminous flame. So by applying non-luminous flame, what will happen? This cupric chloride gives green color. Is it okay? It will give green color flame. So for a change, instead of this cupric chloride, take another one, strontium chloride. So again the same process. Take strontium chloride and add some concentrated HCl solution and make a paste, and please take this paste in a platinum loop in the same non-luminous flame. So here this strontium chloride will gives crimson red color. So here cupric chloride gives green color flame, here strontium chloride gives crimson red color. So the remaining everything is same here in this experiment. In the same way, when we are observing the street lights, so in street lights there is a yellow color flame is there. So this yellow color flame is because of sodium vapors, sodium gas. So by observing all those things, so why do different elements emit different colors? When we are heating with the same non-luminous flame, so here cupric chloride gives green color, strontium chloride gives red color, whereas sodium gives yellow color. Why different elements giving different colors? So scientists found that each element emits its own characteristic color. So because these colors correspond to certain discrete wavelengths of light, and this is called line spectra. So here please once again I will tell you. Spectra means different elements having different wavelengths. So because of this wavelength, this element may having different color. So this is called line spectra. Especially this line spectra is useful to identify the unknown atoms. See, like fingerprints are using to identify the people, like in the same way this line spectra is used to identify the different atoms. So this is also one more important topic regarding this atomic spectrum, atomic structure. Okay, so please note it all. Okay, now we are going to discuss about the atomic models. So there are a number of atomic models are there. So the first model is called J.J. Thomson model. So this J.J. Thomson is the first scientist. He has proposed an atomic model, and he told that, so this is an atom. So in this atom the positive charge is uniformly distributed around the atom. So the negative charge is embedded in this positive charge, just like a watermelon. So in the watermelon also the total red part is there. So this red part is positive charge. So here this seeds are just like electrons here. So that this is the watermelon. So this is why this model is called watermelon model. He explained, he compared the atom with the watermelon. And this is also called plum pudding model. So in this model, the inside the positive charge, there is a negative charge also there present in the positive charge. So it is containing a drawback. Why? Because see, the stable electrons are collapsed with positive charge. When the positive charge and negative charge is inside the atom stable, so the atom may not exist. So how the spectral lines will form, all those things, this theory was failed to explain all those things. The stability concept also will not be explained by this model. So that is why this J.J. Thomson model is failed to explain the stability concept. So to overcome the defects of this J.J. Thomson model, one more model is there. So that is Rutherfords model. So this Rutherford model is proposed by the scientist called Rutherford, and this model is very important model. This model is also called planetary model because he compared the atom with the planetary system. So that is why this is called planetary model and also called nuclear model. So he told that The atoms are spherical in shape, and for example, this is an atom. So this is the nucleus of an atom. So these are the shells. He told that, so this is in the nucleus of an atom, the protons and neutrons will present in the nucleus of the atom. The atom just like spherical, means like a ball. In between at the center of the atom, the positive charge and neutrons will present in the center of the atom. So this is called nucleus. And the electron will revolve around the nucleus just like planets around the sun. So around the sun, the planets revolving around the sun. Just like here, the electrons will revolve around the nucleus. So this is called planetary model. He told this model. So he told one more point. The size of this is the nucleus, you know. The size of the nucleus is very small when compared to the atom. So this is one more point. And he told that the mass of the atom is due to the mass of the nucleus only, because the electrons having very minute value, small amount of mass. So that is why the mass of the atom means nothing but the mass of the nucleus only. So he told in this way. And he explained one more point here. So in this nucleus, there are two types of forces are acting. So here this is a positive charge, you know, this is a negative charge. So in between unlike poles, there is an attractive force is there. So this positive charge means this nucleus is always pulling the electron towards itself because of the force of attraction. So the nucleus is always trying to pull the electron towards itself. So that is one force, attractive force. In the same way here, the revolving electron will having a centrifugal force. Centrifugal force means it is acting away from the nucleus. So the two types of forces are acting at the same time in opposite direction, which means because of the centrifugal force, the electron will fall away from the nucleus. It pulls away from the nucleus. But due to the attractive force, the nucleus is attracting electron towards itself. These two forces will act in the same time in opposite direction. Because of these two forces only, the atom will be stable. He told in this way, the Rutherford. But there is a big drawback in this model also. So according to classical law of physics, while this electron is revolving continuously, what will happen if the electron is revolving continuously means after some time, by revolving the electron continuously, it will lose some energy. After some days, the electron will come closer to the nucleus and fall into the nucleus. If the electron is revolving continuously, it fall into the nucleus means what will happen? The atom may collapse. Matter does not exist. But now atoms will be stable in nature, matter will be exist in nature, which means this concept, stability concept, is not explained by the Rutherford. So this is the big drawback to this model. He didn't give any clear explanation why the electron is stable, why the atom will be stable, how it is stable. So that is why this model is also not accepted. So to overcome this model, again one more new theory is also there. So to overcome the defects in Rutherford's atomic model, so one more scientist called Niels Bohr proposed a theory. So this is called Bohr's atomic model, and moreover this theory is based on the Planck's quantum number. So let us see what are the main postulates of this theory. So in addition to the Rutherford's atomic model, he introduced a new concept, that is stationary shell or orbit. So what is a stationary shell or orbit? He told that, so the electron, so this is the nucleus, this is the electron revolving path. So the electron will be revolving in a nucleus, around the nucleus, with a high velocity in a specific path. So the specific path is nothing but called stationary orbit or stationary shell. Which means in this specific path, the electron having a fixed energy or constant energy. Which means the electron neither gains energy nor loses energy. Its energy must be constant while revolving in this specific path. So this is called a stationary orbit. So this is the new concept proposed by the Niels Bohr. So to overcome the defect in Rutherford's model, he introduced that stationary orbit. So while revolving around this in a particular path, the electron having a stable energy. Means it is neither loses energy nor gains energy. Its energy must be stable, fixed energy. Now he told so many some postulates are there. I will explain. So this is an atom. This is the first shell, second shell, third shell, fourth shell, and so on. Number of cells are there. So first shell is called capital K. It is named with capital K. Second shell, capital L. Third shell, capital M. And fourth shell, capital N. So here this is the first shell, second shell, third shell, fourth shell. So here the first shell having some energy, second shell having some energy, third shell having some energy, which means each shell having different energy. Not all shells' energy is equal. So for example, each stationary orbit corresponding to a certain energy. So first, for example, first orbit having energy 1, second shell having its energy 2, third shell energy 3, fourth shell energy 4, and so on. And here the first shell's energy is less than second shell's energy, and second shell's energy somewhat less than third shell, and third shell's energy somewhat less than fourth shell, like this, because the first orbit having lower energy when compared to the second shell, and second shell having lower energy when compared to the third shell, and so on, like this. And here we have to observe one more point here. The electron, either revolving the electron must be in the K shell or L shell, not in between K shell or M shell or L shell, because the electron must revolving in the K shell, either K shell or L shell, not in between. So this is one point we have to observe. So here already we told that the energy of an electron in the stationary cells is constant, which means it neither loses energy nor gains energy. So here, for example, if an electron, this is the first shell, here one electron is there. So this is second shell, third shell, fourth shell. While giving some energy, for example, this electron is gaining some energy. If it gains an energy, what will happen? It jumps from this shell to this shell. For example, first shell to fourth shell. So this first shell is called lower energy shell or ground state. Ground state means it is lower energy state, which means this is the first shell. First shell means it is having lower energy. So this is also called ground state. If the electron is gaining some energy, it will excited or jumps from lower energy level to excited state. So this is called excited state. So is the electron is fixed here? No. After some time it will again comes to its original position. Means by losing some energy, the excited electron will comes from excited state to ground state by losing some energy. So here excited means higher energy level. So this is very important point you have to remember. See, when an electron is excited from lower energy level to higher energy level, then the energy must be gained here. So E1 means lower energy level, ground state. E4 means excited state. Then the energy is gained here. If the electron is jumps or excited from excited state to ground state, then energy must be loses. So this point you have to remember. It is very important point. Which means from ground state to excited state, energy is gained. From excited state to ground state, energy is released. So how we give the definition difference between the excited state ground state means the energy higher energy level E2 minus E1 is equals to h nu. So this is the equation. Already we know h means Planck's constant and nu means frequency. So this is one more concept we have to remember. So and here this BOHRS model is successfully explained the line spectrum of hydrogen atom. So what is the line spectrum of hydrogen atom? Already we know hydrogen atom will give one color. So this is called line spectrum of hydrogen atom. So this theory is successfully explaining the line spectrum of hydrogen atom. Not only the hydrogen atom, some species like hydrogen means helium plus, lithium plus 2, beryllium plus 3 like this. But it is failed to explain more than one electron like helium, lithium, beryllium and so on. Which means this BOHRS theory is successfully explaining the line spectrum of hydrogen atom and species like hydrogen means single electron atoms. But this theory is also fails to explain the line spectrum of more than one electron elements. But when this line spectrum of hydrogen atom, when we observe this line spectrum of hydrogen atom through a high resolution microscope or spectroscope, what will happen? So again this line spectrum means this one single color again split into thin lines like this. Again it is split into different lines. So this is called fine spectrum. This theory, this BOHRS theory did not explain why this line spectrum is again split into fine spectrum. Again why it is this single color is split into different colors. He failed to explain this concept also. So this is the big drawback for BOHRS atomic model. So again to overcome this defect, one more theory is there. So that is called Sommerfeld elliptical model, and we will discuss that theory in next class. So this is all about today class. In our today class we discussed about the Planck's quantum theory and line spectrum and different atomic models like J.J. Thomson model, Rutherfords model and finally BOHRS atomic model. I think all of you understood well. If you have any doubt you can ask me in the comment section, and if you want more videos like this, please subscribe my channel and like, share to the all. Thank you all.